Bobby retired from the Kentucky Transportation Cabinet after 35 years in the bridge maintenance and research. Now works part-time for Green Peterson, GPI, providing bridge painting, inspection, and project management. Also works part-time for the for University of Kentucky Transportation Center, conducting research for the Kentucky Transportation Cabinet. Please welcome Bobby.
Greetings from the great state of Kentucky. I am Bobby Meade, and sitting on the third row back here is Sudhir Pillai, my co-conspirator in this. And just off to his left a little bit is David Still, who's the one that wants this sort of work done. We work for David. So if you have any really tough questions or anything, I'm going to refer them to those two back there. But let's get started here and just share with you some results from one research study that we did at the University of Kentucky for the Transportation Cabinet and David Still. We all, and we've talked about that while we've been here, have lots of problems with beam ends, and we're going to focus here on the steel beam ends, but some of the problems, and they're common to all of us pretty much, is debris build up, and when we get debris on our beam ends, not only do we get water on there, but that debris tends to hold water and to hold contaminants. And that comes from our leaking joints in most cases. We all have a lot of problems with joints, closed joints that don't stay closed, don't seal. So you end up with those de-icing salts and extended time of wetness, which breaks down protective coatings for anything, but we're focusing on, does the same thing for concrete, but we're focusing on steel for the time being. But this is the sort of thing that we see at a lot of our beam ends. And actually, I've seen bridges in Kentucky where the diaphragms are completely gone, and some, Dave's before yours, where you could stick your head through the web of the beams. I had some pictures somewhere of that. And actually, I've seen a bridge in Kentucky where the debris had built up over the bottom flange because it was in a small town there, and people just tended to throw some trash and stuff around it, and actually there was debris piled up over top of the flange of the beam. So these are the situations we run into. And what can we do about it? Well, we can clean them off, and we need to remove the debris and wash those areas. And then once we get it cleaned, if we want to preserve it, then we need to try to do something about that area. And the problems that we have there then, we have extremely rough, pitted surfaces with high chloride levels. And it's extremely difficult to clean those to any real degree of cleanliness. It makes it very difficult to get a barrier or inhibitor type coating to really last very long at all, to accomplish anything. And what we have seen at the University of Kentucky is even in those areas, if you can get them cleaned fairly well and put a zinc primer on there, you can get some performance out of that. It will shorten the life of it too, but still it will give you a little bit more reasonable life. But those are expensive things to do, and you run into a lot of issues with environmental and worker safety. So Dave was looking for something a little different. And the guidelines we sort of worked under here was that we wanted an effective beam end treatment that would last 5 years minimum, with minimal surface prep, and it had to be tolerant of rough pitted surfaces with some residual chlorides. The intent here was that it would probably be this work would be conducted by state forces. Now, our district bridge crews do a lot of things very well, but to really do good surface preparation and coatings application for high performance coatings is very specialized and very technical, and frankly, they're just not trained in that sort of thing. So we wanted a process by which we could use and obtain some value out of it, but have limited worker safety, limited environmental issues, no special skills or training required, and use very basic tools. So at UK, we decided to look at super barriers, and we solicited dozens of suppliers, and we ended up with literally dozens of applicants, and we selected out of those. We actually had about 24 or 25, and we eliminated a bunch of those because they were entirely impractical to use. Somebody would suggest, you use this 4-foot wide piece of material with adhesive on it and try to get out underneath a joint in a bridge deck, and so half of those we had to, more than half of those we had to just put aside and not try to use. But we ended up using 10 products. There were 4 tapes and 3 adhesive sheets. Now, the difference in the tape and the sheets for us is simply we just looked at the width of the product. If it was 4 or 5 inches or less, we called it a tape, and if it was much wider, we would call it a sheet. We looked at a couple of greases and then a couple of non-traditional liquid applied coatings. We selected a site where Interstate 75 and 64 run concurrent around Lexington, Kentucky, over US 68. This bridge is several spans. I think it is 7 spans, but at the end of the 3rd span is an expansion joint that when we were actually out conducting this work in 2013, I believe it was, when we put these products on, a contractor stopped by and said that he did some work on rehabbing that bridge deck, and that he replaced the joint, and that it had been replaced twice since then, the seals in the joint, because the seals just won't stay in. And as you can see here, we have a lot of evidence of the leaking joint. And as a matter of fact, just outside of the frame on this photograph, it's much easier to see. You can't see it here probably, but there's spalling concrete and reinforcing steel exposed here, and it's just pretty ugly for this pier cap. The steel underneath, alongside this joint, we have the diaphragms that run parallel with the joint, and this is where we chose to put on the beam ends and on these diaphragms, in some cases, our beam end treatments. As you can see on the right side, the seal is gone completely here. This is sunlight shining through from the deck, and you can also see all the debris and stuff that has accumulated down here, and it was worse in a lot of cases. This is a system. This bridge, the original paint is still on it. It was overcoated in 1997, 98. It had a spot clean with a spot application of aluminum-filled moisture cure urethane, a full coat of moisture cure urethane, and then a top coat with a 2-component urethane. And when we did the work in 2013, outside of this joint, I would challenge you to find a square foot of corrosion. It was this overcoat project was done for a little over $1 a square foot and was performing very well. But at this joint, we had a lot of problems. As you can see here, we did some pulls. This is an example of one. They weren't all 1,200 PSI, but they were in that range, 1,000, 1,300, 1,400 PSI pulls. And we did a number of field chloride tests, and it ranged from 15 to 20 micrograms per square centimeter, which is pretty good. Of course, this was done in late April, early May, and it had washed off quite a bit by then. In Kentucky, we used to, and still I think primarily do, when we're doing maintenance painting projects, if we have stratified rust, and I had this discussion with someone previously about my description, packed rust is rust it's in a fading surface between 2 pieces of metal, and stratified rust is just that rust that is not between 2 pieces of metal. If it's between 2 pieces of metal, it's very difficult to get to. But there's a lot of times we have the stratified rust that builds up, and you get the layers, and it may be, it may be a ½ inch thick or thicker, very hard black stuff, and you can power tool it all you want to, and you're probably not going to get it. I've seen it abrasive blasted and remained there, but an impact does a really good job of popping it off. So any of the areas that had some stratified rust, we would pop it off with an impact, use a hammer. Then we scraped the areas to remove all the loose paint and corrosion product that we could. Wire brushed it. This is all SP2 type hand work. to remove any of the loose material around those edges. That doesn't get it all, but it gets some of it. And then we wiped those areas down with burlap. I was surprised at how good a job burlap does for cleaning, but it can clean the surface up very well. And then each location was wiped with a white rag, and those rags were retained for future reference. Then we applied these treatments. One of the things we wanted here was, again, something to apply without a lot of equipment or minimize the preparation work. So I think even these greases like this recommended that you heat them to a certain temperature. Well, we said we want stuff that guys can take out there in a bucket. You can take a wire brush and a scraper and a piece of burlap, and you can clean it, and you don't have to heat stuff. You don't have to have exotic sweat-in times for liquid applied coatings or anything like that. Just basic technology. So this is the grease being applied. This is one of our liquid applied coatings with a brush and a roller. This is a beam ends where we put the liquid applied coatings on one side and grease on the other. This is one of our tapes. Now, during this actual coating applications here, you obviously can see that nobody was wearing it. I had this question once before about respiratory protection. Well, obviously, when we were scraping that paint out there, obviously we were using respiratory protection. Actually, for SP tool cleaning, where we're just removing the surface stuff, and we're not using power tools, you don't mobilize very much lead. Our intent was not to remove any intact paint, just get the corrosion and the loose stuff off. This was one of the products, and we will look at these again in a minute. I'm just running through these now quickly to show you what they look like, putting them out there. And this is one of the problems. One of the things that we did in this study was to try to evaluate the user-friendliness of each one of these coatings. And it was just based on, it was entirely subjective, but it's when the guys was out there, he's like, can I maneuver this material? Is it something like if it's a 2-inch tape and I got to put a lot of strips on there and lap it, that's a little bit of a negative. And they rated these things for user friendliness, the ones that we could apply. This one didn't get real good user friendliness rating because, as you can see, it would tend to wrinkle. It's a little bit tough to use. And this is one of the sheets where it's only 2 pieces that covers the top flange, the bottom flange, the web, and has enough room to overlap. And on some of these, we sealed these edges with a polyurethane caulk, like this one. And a couple of these tapes use a product that it's got the petroleum product, a grease that's with styrofoam pellets that you use to put in these corners or around bolt patterns, because when the tape goes over it, the tape's fairly thick, and we didn't want to leave voids there, so we used that material to sort of round those corners out. And this one did the same thing. This is a different product, but it uses stuff, as you can see in the inset, where we're putting the putty-like stuff in the corners. So this went on in 2013 on the bridge. In 2015 and 16, we've gone back to assess the performance. As you can see here, this is on the left is a liquid applied. It's an aerospace sealant that was brushed and rolled, and over here is a grease, and that's what it looked like in 2015. That's what it looked like in 2016, and I think, yeah, this is one where just a few months back I had the guys go out and just scrape off the spot that had the rust originally, one of the spots. And that area, I mean, it's still got some rust underneath it, but it hadn't grown. It's just sitting there sealed with the grease. The grease is ugly. It picks up, as you can see in the inset, it picks up a lot of debris. It's ugly, but it seems to be doing a pretty good job, pretty low-tech approach. And you can also see the grass and mud and debris and stuff that's on the pier cap and around the bearing there. So it's still getting a lot of water and chlorides washing over it. This is the other grease product, 2015. Same product in 2016. And didn't get as good a pick there, but had them scrape off where that rusted area was. And again, it was like it was when we applied the grease to it in 2013. This is the one product that we actually put on that we feel was not doing a good job. It's a gypsum castor oil liquid applied coating. It's not easy to use. It had a very poor sag resistance and also very poor wetting, so you had to put it on extremely thick to get coverage, and then it would slide off the bridge. In 2015, you can see some rust back coming through it, and that's gradually increasing. As you can see, it's some up the end of the beam and on the top flange and then on the bottom flange. The one product that appears to not be working very well. This is a clear polyester sheet. What it looked like, and then it's one of them that was sealed with the urethane sealer. This is the same product in 2016. We didn't strip it off. We didn't strip all of them off because you can see behind it. This is an aluminum foil sheet that I believe this is one that the guys just went out to the local building supply place and picked up. It's a roof repair product, and they applied this. This is the other end of the same beam, and as you can see, this is an area where we did have some rust underneath, and when they removed this material, again, it had not changed. This is the polyvinyl fluoride or Tedlar tape. Works well, goes on in thinner sections. That's what it looked like in 2016. This is a polyurethane sheet. This is one that it was a little bit easier to work with because it didn't come with an adhesive. You spray the adhesive on, so we were able to manage that a little bit better, so you could spray the adhesive on the surface and then just apply the polyurethane sheet to it, and it has worked very well also. They had those two products that use the putty-like material to fill in the corners. This is one of them. It's a petroleum product. The tape is impregnated with that, and this is what it looks like in 2016. And this was an area that was removed with the rust, and it's a little difficult to see, but you had a bit of rust up and down through here, and it had not grown. This is the other product that was similar to that one. It has the putty-like material. 2016. Actually, the previous one that was aluminum foil was not the roofing repair. I believe this is the roofing repair material here that you can go out to your building supply place and obtain. So at this point, we're still evaluating these. We want to look for a minimum of 5 years of service. We believe that these things can be effective for a very low-tech application. This joint is missing today. And during the winter, all the water and all the salt that's applied to the deck comes down over these materials. And we will continue monitoring these for at least the next 2 or 3 years to see how they're performing. I did want, after some of our discussions yesterday, there was a certain amount of interest in some other data, some other information that I don't have those presentations for here. But I did tell some of your folks that I would include this information. We recently have conducted some projects for Dave again at the University of Kentucky. One of them is evaluating thin film coatings over concrete. And we evaluated 8 different products. And that report has been completed and will be published hopefully within the next couple of weeks. And if you have any interest, you can go to the University of Kentucky KTC, Kentucky Transportation Center website, and look up KTC 1603. And we actually have the names of the products and their performance data and our recommendations in there. And then also we just completed a study. Similar report's been completed. It's in the process of being published of different surface preparation methods for the cleaning of steel for the application of maintenance coatings and the effectiveness of those surface preparation methods in respect to chloride remediation. And I thought that was very interesting, because what we found was that nothing that we do in surface preparation removes the chlorides to the point where they won't be problematic. If you got chloride contamination on a pitted surface, but there are relative effectiveness, and then we looked at like 32 different methods and the combinations of abrasive blast and water jetting and wet abrasive blasting and chemical additives and 32 different methods, and evaluated them as far as the effectiveness of removing chlorides, and then an assessment of the distribution of remaining chlorides, which results in your corrosion cells. So, any questions? Yes, sir.
Wait for the magical talking stick here. You had mentioned that you assess them based on ease of application. What seemed to come out the best as far as you and then the guys who are actually physically doing it were concerned?
Some of those tapes, like the ones with the putty stuff in them, those are very easy to apply. And as a matter of fact, we've taken some of those things and just this wasn't part of a design study of any kind, and put a couple of those on steel panels and drop them in a bucket of salt water and let them sit there a year, and clip the corners off to expose the metal. They do a very good job of preventing undercutting, rust creep, and they're easy to apply out there. Some of the narrow tapes seem to work very well, and they're not at all difficult to apply. It's just that it's more time consuming, because if you got a 2-inch tape and you're going to lap it, then you're out there for a while doing that. Strangely enough, the liquid applied coatings, the two we looked at, were probably more of the ones we could actually use, was probably more difficult to apply. They didn't go on easily. The wider sheets are problematic, because if they come, some of them have almost like a contact cement, and when you get underneath you got limited area, and you're trying to wrestle a piece of material, and if it touches itself or anything else it wants to stick, those can get difficult. So the tapes and the greases seem to be the easiest to apply. You can do it with like the one where you spray the adhesive on. You can do that.
Well, it seems like the grease has the benefit that you can see through it and see what's going on, whereas the tape you need to physically remove to determine.
Right. The grease picks up all kinds of debris. It looks extremely ugly, but it seems to be doing a good job. Over here.
Did you find that the grease went on the bolts and rivets and plates easier than the tapes? It seems like the tapes wouldn't cover, or be harder to cover up some of those.
Right. The greases are fairly easy to put on. I think our ambient conditions at the time we did these applications were in the upper 60s, around 70 degrees, and the steel was, slightly cooler than that, so upper 60s, and the greases are not difficult to put on at all, and you can put them around bolts.
I wonder if this application is good for steel pile, maybe the same thing. In a steel pile, can we do the grease stuff thing?
Before you drive it?
Yeah. Or after, whatever.
If you can get to it after, yeah, I would think it would be
exposed,
helpful.
yeah.
But I haven't had any experience with that. Potentially, I would think.
You raise a very good question. I know in our state we've had a lot of reoccurring issues with steel shell piles with concrete filled, and the outer casings deteriorating, and how to address those, especially in a wet environment, how to recoat or protect them in a marine environment. So maybe this technology might have some application there.
Possibly, and I think neither of you gentlemen had made was in our substructure, superstructure research needs, and that was our primary topic that folks in the DOTs are looking for information about, is piling and the preservation of that piling, and it was also included about surface preparations prior to driving or after they're in place. So that's one of the things that I think we'll probably get some some consideration and research.
More question? Well, thank you very much.